I was, so I'll just start again at the beginning. The shortcut, and one warning real fast. I went on an LDS mission in Virginia, and it was against the rules to take shortcuts through the woods. You know why? You would get lost. Virginia has so many trees that if we were between here and Goddard's room, you would not know Goddard's room was there, even at night. No light would travel there. I lived in a place for 9 months, and it's awkward, but I would pee off the back deck every morning. That was like my favorite thing. And then it was like December, and all the leaves fell off, and there was a house like right where those cupboards are. It was like, oh, like for 9 months. But they didn't see me. I didn't even know there was a house there. Anyway, so you couldn't take a shortcut because you get 25 feet into the woods, and then you have no idea where you're at. So don't take a shortcut if it's going to make you get lost. You with me? Okay, now let's do this. All right. So this process right here is called the picket fence, and it's extremely useful, but it's time intensive, right? In combustion analysis, we always do the same thing over and over. So what we can do is we can say, all right, this part of the picket fence right here is always the same. It's always 1 over 44, 1 over 1, and 12 over 1. It's always that. So what we're going to do is shorten our time is say, all right, I'm just going to take the grams of carbon dioxide, multiply them by 0.2727, and that will give me my grams of carbon. Now, ultimately, I need moles of carbon, but why did I go to grams? Because I have to in order to get oxygen's grams so I can get all of the moles. All right, so remember, this red arrow is here. Remember that you will have to divide that by 12 also. You'll need both those answers. But you can get that really, really quick. You can go straight to grams of C by multiplying by 0.2727. Now, Taylor, I'm going to shorten this all up. There's some instructions for you. All right. Then, hydrogen works the same way and is even better. Hydrogen, you just take water, multiply it by 0.1111, because that's this part reduced mathematically. It's just that value every time. What is awesome about hydrogen? Okay, its moles and its grams are the same value because it's just a 1 right there, right? Okay, so right there, within maybe 30 seconds, you could get these two numbers. You need a third number. Divide that by 12, right? You need another number, and that's when you add the two of them and subtract from your initial.
So that's only if you need oxygen.
Yeah. Don't bother on this if you don't need oxygen. You just, what was the numbers we came down to? Divide it by 44 and divide it by 9, right? All right. Once we have our oxygen, we divide it by that, we get the moles, and then we can do everything as we always have. Okay, now that's a lot. Like today's announcements, who got anything out of those this morning?
I totally.
That's too many words, right? Too many words. They were read fine, like she was nice and clear, that super high squealing wasn't there, but I got nothing. Like, I know it's HOSA week. I know something about the FFA and Sarah Draper. And I think I'm done. Something about swimming. Something about saddle, but she said straddle. Straddle strings. Like, whoa! All right, so here, this sums it up. Did we already write these down? Oh, okay. Okay, so look, and you might not like the order. It doesn't matter. You don't have to go in this order. But multiply CO2 by that number, that'll give you grams. Multiply water by that number, that gives you, grams of C and then grams of H. Then, this is all the same. Add them and subtract them to find oxygen. Divide it by 16 to get the moles of oxygen. Divide number 1 by 12, which you probably already did because you're an efficient kid in the first place. Divide number 2 by 1, which is pointless, but it's just to maintain the idea. You with me? Now all three of those are in moles. Divide by the smallest number to find the formula. If your formula doesn't add up to the molecular weight given, then you have to manipulate it. Okay, so see how quickly you can attack this one? Do your best. All right, so these are our two answers. So we would call this the empirical formula. This would be the molecular formula. If you're ever given this, then that means you have to do the extra step to find the molecular. So the way that works, once again, you add up all the parts in here. You have 12 plus 16 plus 2. That is 30 grams. This tells you that it should be 90. Well, how does a 30 become a 90? Times it by 3. So that's how this subscript of a 1 became a C3, a 2 became a 6, and a 1 became a 3. Okay, one more time. Who had both? Raise your hands again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, who had at least one of them, right? Keep that up too. 1, 2, 3, 4, 5, 6, 7, 8. Some of you put your hands down. You can't have both right, but only one right. Okay. Now, the way that we did this, like, I would hate if I was you to look at my thought process here. But I took my hydrogen value, and that might be confusing. Almost every one I've given you C first. On this one I gave you H. But I kept the green and the red, whatever. So I took hydrogen, I multiplied it by this new constant, which is what the picket fence would have been, and that gave me 1.164 and 1.164 because hydrogen, the grams and the moles are the same value. I took my carbon and I multiplied it by the new constant of 0.2727, and that gave me 6.99. This one, though, that was grams, so I divided it by 12 while I was there, and I got that number, and that was my moles. Okay? A lot of people, first hour, that got this wrong, they kept 0.699. They forgot to divide by 12. Okay, then to find my oxygen, I took my initial given amount of my CHO, and then I took the total of my grams H and my grams C, and I subtracted it. Okay, a lot of people that got it wrong first hour, they divided that number by 16, not the difference by 16. All right, when you do that, you get 9.31. Then that's grams, so you have to divide by 16, and you get 0.58. Now you have all three in moles. 0.58, 0.58, and 1.164. This one, you could do this one in your head. These are both ones, and 1.16 is definitely twice as much as 0.58, right? So you end up with CH2O every time. All right, that's your empirical. Then you need molecular to equal 90, and you're off to the races. Okay, if you're 100% with me, raise your hands. Well, that's way more people than I thought would be. Okay, what I'm going to do, only 14 people have turned in this section of homework. So what we're going to do, I'm going to put one more example up. If you're struggling at all, try that one. And then if you haven't submitted section 2, go ahead and grab an iPad, and you can work on that. And the first hour kids pointed something out I did not know. In Guru on the iPad, it doesn't let you scroll lower in your form or on the PDF. but they're both there on BEHS Science. So you can go to Chapter 3 in BEHS Science and access both of those. You with me? So we'll kind of take today and have it a catch-up day. Some of you still haven't even turned in the Section 1 homework. I've moved the test to next Tuesday instead of Friday, but that is the drop-dead date. We will do it on there whether you are ready or not. We should be ready, but we got to get this done. Close your eyes for 10 seconds. Ready? 1, 2. Oh, never mind. I thought I had the answers up still. Okay, go ahead. If you still need work, just do Part A. You can't do Part B because half of it's not on the screen. Part A is the CHO. It's just what we've been doing if you're still struggling. If you're not, then grab an iPad, do some work. If you've submitted Section 1 and 2, then feel free to start looking at Section 3.